Welcome to AP Euro for Winners.
Today, we are starting off talking about Unit 4 with the scientific revolution, which, side note, is occurring at the exact same time as Unit 3 and Unit 5. And when you combo the scientific revolution with our next lesson of the Enlightenment, both are known as the Age of Reason. So let's get into some context. What did the world look like before the scientific revolution? So we have the growth of universities throughout Europe, which is going to enable new disciplines outside of theology to be studied. We have the Renaissance that's occurring, which is introducing math and kind of adding some more importance to math, enabling a better understanding of the physical world. And as always, my favorite is the printing press. People are starting to be able to share their ideas with one another and around the world. Arguably, the most important thing here is that the center or the basis of knowledge during this time is really based on the Bible and the Catholic Church and what they say. They're going to believe that science lives in the world of theology instead of being in opposition to it. So the cosmos, for example, they're going to say are governed by spiritual forces. And their big theory, right, at the time theories accepted as fact, this is back then, is the geocentric theory. And this is a model from ancient Greeks. We have people like Exodus, we have Aristotle, we have Ptolemy, all going to back this traditional worldview where everything in the universe revolves around the earth. If you look at the graphic on the right, the sun, the planets, everything revolves on the earth. And the theory at this time was, well, if we were moving, we would feel it, right? If you look up at the night sky, everything else is moving, we're not moving. The Bible says the earth was created first, then we're at the center. So this is the geocentric theory.
Then things changed. In 1540s, we get a guy named Nicholas Copernicus. And he comes up with the idea that the earth revolves around the sun. Whoa! It's called the heliocentric model, okay? As opposed to the geocentric model. Heliocentric, helios, sun, right? The sun's the center of the universe. He writes this text in 1543 on the revolution of the celestial spheres. Wow. So he's pretty terrified to publish his own ideas that, like in this book, because the Catholic Church has all the power, right? He doesn't want to be accused of heresy, all right? And this book isn't actually published until 2 months before he dies. And he's actually on his deathbed in his 70s when he receives his first copy of the book. But his ideas, even though he spreads them right at the end, his ideas spread thanks to the printing press, and other people start to hear about it, and scientists at the time get excited, and they're like, oh, I think this might be right. And he's got this quote at the bottom, okay? Therefore, when I considered this carefully, the contempt which I had to fear because of the novelty and apparent absurdity of my view nearly induced me to abandon utterly the work I had begun. So the fear of the repercussions from going against the Catholic Church was so great, he almost just took everything away that he had to say.
And then comes Johannes Kepler. So he is an astronomer and a mathematician. He is religious, just like Copernicus and all these people we talk about are going to be religious today. He is Lutheran. But because we're going to see some of his ideas that come out, he is going to be forced to relocate a bunch of times to avoid persecution from the Catholic Church. But he still believes in God. He's trying to find a connection between the physical and the spiritual worlds. He believes through his findings that he has uncovered God's geometrical plan for the universe. So again, he's kind of still using a religious lens to justify his scientific discoveries. Now let's get into the science lens. He comes up with and finds these laws of planetary motion. And these are all going to expand upon the heliocentric model and add a little bit of math and science proof behind what Copernicus hypothesized. And the actual math of it is over on the right side. You definitely don't need it, but it looks pretty cool. So the first law of planetary motion is that planets orbit the sun in patterns, so they're predictable. He can tell you where Jupiter is going to be in the sky at a certain date, which shows that it's moving. He's also going to say that planet speed varies, and they're going to travel in elliptical orbits rather than circular orbits. So he's going to observe that planets pass by the sun at different speeds. They're going to move faster depending on their position to the sun, right? The closer to the sun the star is, or the planet is, the quicker it's going to go into orbit. Just a little side note at this time, while doing this, Johannes Kepler is still going to focus on putting out daily horoscopes. which kind of shows that a lot of people still believe in astrology. They're still not really buying 100% into this new math and science and these new theories about the world around them. So we still have that traditional thought, even though there's a lot of changes going around. So alchemy is still going to be practiced. Here's another example where it's kind of an old method where they think they can turn base metals into valuable metals. It's proven today that they can't. So, for example, thinking they could turn lead into gold, now we know it's not even possible. Back then,
it's possible if you had like a super hydrogen collider or something and you smashed those things at but yeah, it wasn't possible back then.
Yeah, that did not exist back then. But they kept trying to do it. So there is some traditional thought that isn't really buying into all this science and math going on.
So all of this kind of is leading into the scientific method, which is a part of the scientific revolution. And the scientific method we could think is coming about at around 1620. And we can talk about two specific people that sort of launch it off: Rene Descartes and Francis Bacon. And they're going to share the scientific belief that the natural world could be explained through logical and abstract thought and scientific evidence. So we can use scientific evidence to explain everything around us. So let's talk about Descartes. He's going to use something called deductive reasoning. College Board needs you to know this. So here's what deductive reasoning is. We're going to doubt everything in the world so that we can try to assess what we know with a fresh perspective, clear of any preconceived notions. So doubt everything so that you can learn it all again. You find out what's true in the big picture, and then you try to move smaller into the details. And this is going to clearly establish general principles and then move from those to the establishment of specific truths.
Then we have Francis Bacon, who's actually going to bring us into inductive reasoning. So this is going to be the testing and refining hypotheses through observation, measurements, and experimenting. They're kind of opposite of Descartes. Bacon's going to go from the small picture to the large picture. So he's going to observe the smallest parts of the world and then apply those findings and generalize them to larger concepts, right? So he's going to set up experiments. He's going to manipulate nature on those small levels. He's going to attempt to prove hypothesis right or wrong. All of these things are through empiricism, which is just fancy word of gaining knowledge through inductive reasoning, right? Using those experimentation to then draw truth from that. And because of this, he starts really small and kind of wants to manipulate his experiments to see what's true and what isn't, he comes up with a scientific method. He's known as the father of that method. And this is going to argue that you should use inductive methods for scientific inquiry, right? Science should be pursued in a systematic, step-by-step method. If you follow the step-by-step method, it will lead you to more knowledge and truth. You cannot accept anything as truth unless it has been proven through this step-by-step method. So this is kind of developing a standard for accepting truth, finding out new knowledge, all of these things.
All right, now we got another figure in the scientific revolution, Galileo Galilei. Okay, so he's around in the same time period, 1620s. He's a mathematician, physicist, and an astronomer. And he, like all these other people, very religious. This guy's a Catholic, all right? He's known as the father of modern physics and the father of observational astronomy. For example, he builds a telescope that's 30 times better than any telescope that existed at the time. Crazy. You can see it in the top right there, okay? And he builds a thermometer. Cool. All right. So he does a lot of observations around space, right? And when he's observing space, he finds Jupiter. He finds 4 moons for Jupiter. Okay. These are the 4 biggest moons that Jupiter has. Jupiter just, it's like 60 plus moons. These are the 4 biggest of them. Okay. And basically he realizes that not everything's revolving around Earth. These moons of Jupiter are revolving around Jupiter. So it goes further to disprove that geocentric theory. He also figures out that the moon isn't smooth because it has craters and mountains, that the sun has sunspots, which are basically like where it's hotter or colder. And these are the ideas that like the heavens aren't perfect. There's imperfections in all of these things. So further moving away from the Catholic Church. So continuing on with Galileo, His research and data, like we said, supports Copernicus' theory about the heliocentric theory. And as he starts to publish all his works, tension starts to build. Who do we think is going to dislike this? Oh, yeah, the Catholic Church. Okay. So they're going to start to warn him about publishing too much stuff. And he thinks that he could publish his findings if he tried to come off as like neutral and he was just like, hey, I'm just presenting information. And so he writes this book called The Dialogue Concerning the Two Chief World Systems. Basically, like, oh, there are these two ideas. I wonder what people think. You know, he talks about the heliocentric theory, the geocentric theory, and he tries to stay impartial. However, 1633, he gets charged with heresy and he faces death by burning. Okay. But he decides, never mind. My theory was wrong. I recant everything. I was wrong. He gets sentenced to house arrest, spend the last years of his life under house arrest, and he dies in 1642. But so I just want you to show a couple of things with this, right? Like his ideas were so powerful to the Catholic Church that they put him on house arrest. And he is so worried about it that he takes everything back that he knows in his heart is true. Okay. And it's going to spark a ton of discussion and questioning and debates about science and the role of the Catholic Church. Why does the Catholic Church care so much? They're losing their grip on society, right? They were the ones that controlled all the information. And now they're realizing maybe they weren't right. Maybe they're not infallible. So this is a big deal for the Catholic Church. So to wrap up with Galileo, these are just some quotes.
On his way out of the courtroom, he is kind of known for saying, and this is not in the native language that he said it in, but the English translation is, and yet it moves on the way out, because he was just forced to recant his theories to avoid being put to death. And it's kind of like a metaphorical middle finger to the church and being on trial of saying, yeah, I just recanted all my stuff, but yet the earth still moves. Like, I am still right. So on his way out of his trial, that's what he's quoted by saying, kind of mumbling under his breath. But really important, this would be the equivalent of nowadays something going viral. This really sparks a lot of conversation among the average person and the common folk and anyone that has access to a printing press that can read. Really big news. Now we've got Isaac Newton. This is a name that I know a lot of us are familiar with, but we have to kind of connect him to the scientific revolution. So he is going to come about in the late 1680s. He is going to write Principia Mathematica, which proves Kepler's laws of planetary motion from a force-based theory of universal gravitation. So he adds it. He's proof. Like, you can't deny this math and science behind it. It's right here. And then he comes up with the law of gravity, right? The Earth has its own gravity. It's proportional to the object's mass. So our gravity is different than other planets' gravity. He's going to remove any leftover doubt about the heliocentric theory of why the Earth, which is a smaller body, is going to rotate around the sun, a larger body, gravitational pull towards the sun. And why, when you look up to the sky, we are moving, but we don't feel it. And then lastly, he's going to have his 3 laws of motion. And these are natural laws that explain the order of the universe. They can say, or with this, Newton can say that the universe can be measured and predicted. He's going to say that while, because remember, Newton's still religious, all of these people are religious at this time, he's going to say that God is not actively participating in the universe. He exists, he's there, he's still doing all the things that we know he's doing, but he's not actively participating. So it's okay for us to look into the science and math behind these other things. That's called deism. We're not going to ask you what the 3 laws of motion are. You don't necessarily need to memorize them, but just know that it's applying natural laws to the order of the universe.
Your science teachers would want you to know, though. Some other noteworthy things about the scientific revolution that Calvert wants you to know are kind of related to medicine. So this first guy is some context. He's not going to be on the exam, but he's good to know about because it kind of proves why these other people come about. His name is like Galen, I think. Okay. And he's a Greek physician, a surgeon, a philosopher. And he has this idea that when you're sick, it's because you have an imbalance of your humors. And he says that our bodies are made up of blood, phlegm, black bile, and yellow bile.
Yum.
And so if you're sick, that's when they would like put leeches on you or bleed you out because he's like, well, you have an imbalance in these humors, so let's bleed you so there's less blood. Right? I don't know. He's got these ideas about how to make people sick. That's how people lived for like 1,500 years. They're going with these ideas. No wonder people died so early. You're sick, they're going to make you bleed. Okay. Anyway, so then we get William Harvey in around 1600, and he's the first to show how the circulation of blood in the human body works. And he uses experiments and arguments to support his idea, scientific method. He shows that arteries and veins are forming this circuit that starts at the heart and then eventually comes back to the heart. Okay, so he's showing how blood works in the human body, sort of proving Galen wrong, right? Then Andreas Vesalius in the 16th century. He's the father of modern anatomy, which is how the body works, how the body looks, and he begins modern medicine. He has this book, Fabrica, that he writes, and it's the first sort of accurate book on human anatomy, where we're getting some better ideas. And he proves Galen wrong on a lot of different accounts. So it's important that we're using the scientific method now to prove these previous people wrong. And the last guy Calderwood wants you to know is Paracelsus. And he pioneers the idea of using chemicals and minerals in medicine to make you feel better. So they use things like mercury and lead and arsenic that he might think of as cures. Now, some of these might not have worked. But if you think about today, we still use chemicals and minerals to cure things, okay? So he's arguing the body is a chemical system. It's not about humors, right? And we need to balance it internally and environmentally, which, while not 100% accurate, is at least closer to what we know today.
And also, just a kind of a fun fact that really baffles my brain is that with the printing press sharing all this information, at this time, if you're drawing a human body, you then have to draw it backwards because the printing press needs it backwards to then print it forwards. So not only are they looking at a body and they're drawing it, you then have to draw it backwards and mirror image. So imagine all this stuff that we have that looks pretty decent from back then, and to make that happen, it's pretty cool.
So they had to write backwards?
Mm-hmm. They had to put the text in backwards. Yep. Here are the historical developments that College Board wants you to know. Read them. As always, thank you for watching. Shout out to our amazing AP Euro class. Thank you all. And we will see you for the next video within the age of reason, but about the Enlightenment.
Until then, bye.